Okay, so today we're going to talk about the rule test to see if an infinity series is convergent or divergent. I think in the previous episode we talked about the Rachel test, and today we're going to talk about rule test, which I think is a little bit similar to the Rachel test. Why would I say that? You may think it's a little bit confused because it's actually like very different, but I will let you know which part a little bit looks similar. Okay, so what is a rule test? How to do it? Let's say we have a infinity series here, summation an n's from 1 to the infinity, and we want to know if it is convergent or divergent by using a rule test. Okay, rule test. Yeah, this kind of look like root as well. So how do we use the rule test? So I told you limit as n approaches to infinity of nth root of absolute value of a sub n equals to p. And it told you, oh, here is important. If p equals to 1, it's going to be something. And if p less than 1, if p greater than 1, it's going to be something. Which this part I think is a little bit, not a little bit, I mean like quite similar to a Rachel test, because as we all know, in Rachel test, this one will be meaning inconclusive. So here also, so it's inconclusive. As n equals to 1. No, I mean p equals to 1. So if p is less than 1, then that means it converges. And if p greater than 1, it's going to be means divergent. This part is very similar to the Rachel test. If you forgot, I will write down here. So for the Rachel test, okay, I should align them. So for the Rachel test, limit as n approaches to infinity, a sub n plus 1 all over a sub n equals to p. So here it's the same thing. So if p is equal to 1, that means you need to use another method because it's inconclusive. And as p is less than 1, which I told you guys why when it's less than 1 it's going to be divergent. Yeah, because you need to observe here the numerator and denominator, then you will see why. Okay, so this is going to be divergent. And if p greater than 1, so it means it's going to, oh yeah, sorry, convergent. I don't know what I was talking about. Okay, here it's going to be divergent. So this is the part that I think are similar. But this part, of course, is different test, so it's different. But this part looks same. Yeah, looks similar. Okay, let's keep talking about the rule test here. Okay, so now we know how to do a rule test. Let's make an example here. So let's say we have a summation n start from 1 to the infinity n plus 1 to the power of n. And we want to know if this series is convergent or divergent. So let's use the rule test here. Actually, because I'm talking about the rule test today, so you know we are going to use the rule test. But a lot of time you saw infinity series, you're going to observe first. Then it will save you a lot of time. Why I say that? I mean, like there are a lot of tests that you can use, and if one doesn't use is not useful, then you can always use another one to test. But what if first you observe, and then it will save you a lot of time by choosing the correct and the simple way to testify if it's convergent or divergent. So as you can see here, like directly, you can see here is to the power of n. I need to use the same number, same color. So it's to the power of n. So this makes me think about I will use rule test. Why? It's very simple. Because you know a to the power of n, oh no, sorry, is nth root of an. This can actually write down like a sub n to the power of 1 all over n. So if you use a rule test, this value is going to be disappear. Okay, so let's see if it is actually using rule test in this case. So for rule test, okay, so I need to make it smaller. Okay, so for the rule test, limit n as n go to the approaches to the infinity, nth root of 1 all over n plus 1 to the power of n will be limit as n approaches to infinity, 1 all over n plus 1 to the power of n. And we wrote this part as to the power of 1 all over n. So as you all know, if I have a2 to the power of 2 times a to the power of 3, it's actually add together, right? It will be a to the power of 5. But in this case, it's like a to the power of 2 to the power of 3 will be a2 times 3, which will be a to the power of 6. Okay, so this part is going to be cancelled out and be 1 to the power of 1. So let's keep going. So it will be limit n to the, as n approaches to the infinity, 1 all over n plus 1. So you can see here, it's going to be infinity, right? So when your denominator is going to be very big, it's going to be 0. So this will be 0, which 0 is less than 1. So that means it's convergent. Okay, that's the rule test.